Okay, in this section we're going to look at linearization and differentials. In this first recording we will look at linearization. Here we have a picture of a curve f of x, and the tangent line to that curve at a point x equals a and y equals f of a. In order to find the equation to the tangent line, we plug into the formula y minus y1 equals m times x minus x1. Now remember, our m, our slope, is the derivative at that point. And so if we take that formula and we plug in a for our x1, f of a for our y1, we call our y L of x, then we have the formula that you see at the bottom there, which is the linearization of our graph. Now if f is differentiable at x equals a, the approximating function, L of x, is the linearization of f at a. Now this approximation, f of x, is approximately L of x if we are looking at a value that's very close to a. Now a is what we call the center of approximation. For a very brief interval to either side of a, the y values along that tangent line will be very good approximations to the y values on the curve. Now here's an example. We have a function f of x equals the square root of 1 plus x, and we want to find linearizations at two different points at x equals 0 and at x equals 3. And the first thing I'm going to do is I'm going to write f of x in root or power form. That is 1 plus x to the 1/2, because that will make it easier for us to find the derivative. If that is f of x, then the first derivative is a power rule. That's 1/2 times 1 plus x to the negative 1/2. Now this is a chain rule since we have a function in a composite function. But now the derivative of 1 plus x, the derivative of 1 is 0 and the derivative of x is 1, so we really don't even have to find that derivative because it's just going to be 1. So this will be 1 divided by 2, and if I bring the 1 plus x to the negative 1/2 down to the denominator, that's the square root of 1 plus x. Okay, now I want to know a linearization at x equals 0. Okay, so for x equals 0, what we want to find first is f of 0. That's what I get when I plug 0 into my original function. The square root of 1 plus 0 is the square root of 1, or 1. Then I want to find f prime of 0, and that's what we get when we plug into our f prime function, which is 1 divided by 2 times the square root of 1 plus 0. 1 plus 0 is 1, the square root of 1 is 1, and 2 times 1 is 2. So that's 1/2. Now to find our linearization, L of x, we are going to find f of a, or f of 0 here, plus f prime of 0. And we're going to find that, and we're going to multiply that by x minus 0. So here f of 0 was 1, plus f prime of 0 was 1/2, times x minus 0. That is 1 plus x minus 0 is x, so 1 plus 1/2. So if we're looking at points that are very close to 0, this function will give us a very good approximation to the actual value on the graph. Now this is for x equals 0. We also want to do this for x equals 3. So first we have to find f of 3, which is the square root of 1 plus 3, or the square root of 4, which is 2. Next we need to find f prime of 3. That is 1 divided by 2 times the square root of 1 plus 3. We just saw the square root of 1 plus 3 was 2, so that's 1 over 2 times 2, or 1/4. Now to find the linearization, we're going to plug into the same formula again. So this will be f of 3 plus f prime of 3 times x minus 3. Now let's simplify. F of 3 we said was 2 plus f prime of 3 was 1/4 times x minus 3. To simplify this, we can distribute 1/4 times x is 1/4 x. 1/4 times -3 is -3/4. Collect your like terms, you'll have 1/4 x, and 2 minus 3/4, remember 2 is 8/4, so that will give us plus 5/4. So if we pick points that are right around 3, this function will give us a very good approximation to the actual function value. Now here's a picture of the graph, the square root of y equals the square root of 1 plus x, and you can see a linearization at 0 and at 3. And right around those values, you can see the little green box there. If you're looking right around x equals 0, then that tangent line is going to be very close to that curve. Here's a magnified view, and you zoomed in a little bit here close to x equals 0, and you can see that those two lines, one's colored in pink and one's colored in blue, are very close to one another. Now let's find one other linearization, and that's the linearization of f of x equals cosine of x at x equals pi over 2. Well, the first thing we need to do is find f prime of x. Remember, the derivative of cosine x is negative sine x. Now we are looking at x of pi over 2, so I'm going to find f of pi over 2, which is the cosine of pi over 2. You'll remember that the cosine of pi over 2 is 0. Then we're going to look at f prime of pi over 2. That is negative sine of pi over 2. Remember that the sine of pi over 2 is 1, so this will give us negative 1. Now to find the linearization, we will do f of pi over 2 plus f prime of pi over 2 times x minus pi over 2. We found f of pi over 2 to be 0. F prime of pi over 2 is negative 1 times x minus pi over 2. So the 0, of course, goes away. Negative 1 times x is negative x, and negative 1 times negative pi over 2 is positive pi over 2. Now if you look at the graph, you'll see that line, y equals negative x plus pi over 2. And if you look at points right around pi over 2, you'll see that this tangent line and this graph are very close.